Okay, let's dive in. We have a fascinating stack of sources today. The 10 most viewed publications of 2025 from Amazon Science.
Yeah.
And we're not just talking theory here. This is the research that's, actively building what's next in everything from frontier AI to deep system security.
And what's really striking is how the research clusters. You can see these clear, high-impact areas emerging. We're talking generative AI, formal verification, and some really advanced robotics.
It's the stuff that's shaping the infrastructure we all use.
Exactly. And it's shaping how you're going to interact with technology pretty soon.
So let's start with the new engines, the Nova family.
Yeah.
The one grabbing all the headlines is, of course, Amazon Nova Premier.
The big multimodal model.
Right, and everyone is talking about that 1 million token context window. I mean, that's not just a bigger number, that's a fundamental change.
It really is. Think about it. It means you can throw a massive code base or a huge financial report or even hours of video at it in one go.
No more chopping data up into little pieces.
Precisely. That whole complex chunking infrastructure just, it goes away. And while Premiere is for that heavy lifting, there's also Amazon Novasonic.
Which is all about the conversation itself, right? The actual interaction.
Yeah, the breakthrough there is that it unifies speech and text processing into one single architecture.
And what does that mean for us, for the user experience?
It just kills the latency. You know that awkward pause in most systems where it's clearly thinking? That's because it's translating speech to text, then processing, then translating back. Novasonic does it all at once. It makes the conversation feel, well, natural.
So the AI can interrupt, it can follow up. It's more of a co-pilot than a Q&A machine.
Exactly. But all that power, you need to be able to control it.
Which I guess is where the Nova 2 family comes in. They introduced this feature called extended thinking controls.
Right, so you get to decide. You can tell the model to be fast, or you can tell it to be more thorough and accurate, depending on what you need.
And that idea of control leads right into the safety side of things.
It has to. With models this powerful, security can't be an afterthought. The new Frontier Model Safety Framework is their answer to that.
So how does that work?
It's basically a three-step process.
Yeah.
First, you define what a critical capability is, what could cause harm. Then you evaluate for it, with humans in the loop. And if it crosses a threshold, you implement risk mitigations.
Okay, now this next part I found absolutely fascinating. Moving from safety frameworks to mathematical certainty and security.
The AWS paper.
Yes, they needed absolute proof for their cloud authorization, who can access what. And instead of just testing their old engine forever, they rewrote it.
In a language called Daphne, which is verification aware. I mean, this is so cool. It's like proving a theorem in math. You're not just showing the code might be correct through testing. You are proving it is correct with logic.
And the result was, what, a threefold performance boost?
Yeah. So they got perfect provable security and made it 3 times faster for customers. It's a huge win.
It's that same kind of rigor we saw in the paper on statistical power calculations revisited. Just making sure the results aren't just statistically sound, but actually mean something.
Right. Which, let's shift gears from the digital to the physical world, because the progress in robotics here is just astonishing.
Okay, Vulcan pick. This system solves such a tricky physical problem. It can pick a specific item out of these densely packed fabric pods.
And fabric is a nightmare for robots. It's not rigid, it deforms, it's unpredictable.
But they cracked it. The proof is that it processed over 12,000 real customer orders in a live warehouse. This isn't a lab demo.
Not at all. And then you have the other side of that puzzle, the stow system, which is all about packing things in.
Right, and the innovation there is that it can handle deformable storage spaces.
Yeah, it can compress and shift things around to pack with human-level density and speed. We're talking over 500,000 stows completed. These systems are scaling and fast.
So when you zoom out, what this all really shows you is a very clear strategy. You build these incredibly powerful AI models, you lock down the core systems with mathematical proofs for security, and then you solve the messy physical world problems with advanced robotics. It's all connected.
It is, and that leaves you with a really important question to think about. We're seeing models like Nova. We're seeing dedicated AGI labs being set up. So how quickly do these scientific papers stop being academic and just become the default foundation for every single enterprise app you use?
That gap between the lab and the real world.
It seems to be closing faster than anyone, really predicted.